Post-designing and PCB fabrication process. Following the successful design of your PCB layout, the next stage involves the fabrication process, which transforms your digital design into a physical circuit board. Printing the design. This stage involves transferring the PCB layout design onto a special photoresist-coated material typically made of copper foil laminated onto a substrate. Two main methods are used. Direct imaging, DI, utilizes lasers to directly image the design onto the photoresist. Photolithography employs photomasks and UV light to transfer the design pattern onto the photoresist. Etching. The exposed photoresist is removed using a chemical solution, leaving behind the desired copper pattern on the board. Essentially, the unwanted copper is etched away, revealing the designed circuit traces and paths. Drilling. Holes are drilled at specific locations on the PCB to accommodate component leads and mounting hardware. The drill size and hole plating, optional, are crucial for proper component connection and reliability. Interconnecting and packaging electronic circuits, IPC, standards. Holes are drilled at specific locations on the PCB to accommodate component leads and mounting hardware. The drill size and hole plating, optional, are crucial for proper component connection and reliability. Gerber Generation. The completed PCB design is translated into Gerber files, which are industry-standard files containing instructions for the PCB fabrication process. These files define various aspects of the PCB. Copper layers for each circuit layer. Drill files for creating holes. Silkscreen and solder mask layers for marking and component placement. Soldering and De-soldering. Electronic components are soldered onto the designated pads on the PCB using solder paste and a soldering iron. This process requires careful attention to component placement, soldering techniques, and proper heating practices. Desoldering might be necessary if components need to be removed or replaced. Component mounting. Through-hole components are inserted into the drilled holes on the PCB and soldered from the bottom side. Surface mount components, SMDs, are placed on the designated pads and soldered using techniques like reflow soldering or hand soldering. PCB and hardware testing. The assembled PCB undergoes rigorous testing to verify functionality and identify any potential issues. Various testing methods can be employed, including visual inspection, checking for component placement, soldering quality, and potential defects. Electrical testing, measuring voltage, current, and signal integrity to ensure the circuit functions as intended. Functional testing, verifying the overall functionality of the circuit based on its design specifications.